All right, so the next thing we're moving on to is method of difference. Now, the method of difference is used to find the sum of a series whose general term can be written as the difference of terms. If we can write UR to be equal to f of r plus 1 minus f of r, then the sum of the series can be found as follows. Now, the sum of UR, which is a series from R to N, is equal to the sum of f of R plus 1 minus f of R, because that's what the series, the general term, was equal to. Now, to get the series, I'm going to put in values of what R, from R is equal to 1 to R is equal to N. So when R is 1, you're going to get what? The first term is going to be f of R plus 1, which is 2, minus f of R, which is f of 1. So this would be the first term. That would be the first term. This would be the second term. This would be the third term. This would be the n minus 2 term, because it's, no, it would be n minus 3, the n minus 3, because you have to add 1. N minus 3 plus 1 gives you what? N minus 2, don't it? So this is the n minus 3 term. No, it's n minus 2, because it's n minus 2 plus 1. So this is the n minus 2 term. From here to here is the n minus 2 term. Then this would be the n minus what? 1/3. Sorry, not up to there. To here, that would be the n minus what? 1 term. And this would be the nth term. Now, what you'll notice is that if you observe, you'll notice that f of 2, you have positive f of 2 and you have minus f of 2. So that gone, don't it? That zero out. You have positive f of 3, you have negative f of 3. Positive. So therefore, the assumption is that if you have positive f of 4, you're going to have negative f of 4, don't it? So all of the terms are going to zero out, and you'll notice that this says f of n in the last term. Where can I see f of n? F of n minus 1 plus 1 is f of n, don't it? So f of n goes, what is left is what? F of n plus 1 and f of minus 1, don't it? So the sum of the series would be equal to that. It will be equal to f of n plus 1 minus f of n minus 1. Let us try and see this in action. I'm going to do example 15. Example 15 says, show that 1 over r into r plus 1 is equal to 1 over r minus 1 over r plus 1. So that is partial fraction, which we all know. This would be equal to a over r minus 1 over, b over r plus 1. Plus b over r plus 1. So now this would work out to be 1 is equal to a into r plus 1 plus br. Now I can start by saying when r is equal to 0, we have 1 is equal to a, 0 plus 1, and b times 0 would have gone, don't it? So a here is equal to 1. Then I'm going to say when r is equal to minus 1, I'm going to get 1 is equal to the a gone, and I'm going to have b times minus 1. So b would be equal to minus 1. And then 1 over r into r plus 1 would be equal to a over 1, a over r plus b, which is minus 1 over r plus 1. So we're asked to show that. Then we're asked to find the summation of this series. We're asked to find the summation of the series from r is equal to 1 to n of 1 over r into r plus 1. And this can be written as the summation from r is equal to 1 to n of 1 over r minus 1 over r plus 1. So let us write this out. If you write this out, it's going to be equal to, when r is 1, you're going to have 1 over 1 minus 1 over 2. That's the first term. Plus, when r is 2, you get 1 over 2 minus 1 over 3. Second term. Third term, 1 over what? 3 minus 1 over 4. We can't list all of them. So let's go to when n is what? When r is what? N minus 2. We'll have 1 over what? N minus 2 minus 1 over n minus 2 plus 1, which is n minus 1. When r is n minus 1, all right, I don't have enough space. So let's start up here. So when r is n minus 1, we're going to get 1 over n minus 1 minus 1 over n minus 1 plus 1, which is n. Then when r is n, we get 1 over n minus 1 over n plus 1. So what we'll notice is that them two are gone, don't it? Them two are gone. And it's reasonable to assume that this is gone too, this is gone, this and this gone. So the only thing that remains is what? 1 minus 1 over n. So the summation of this series, from r is equal to 1 to n of 1 over r into r plus 1 is equal to 1 minus 1 over n plus 1. If I want, I could simplify it to n plus 1 minus 1 all over n plus 1, which works out to be n over n plus 1. The summation of the series, 1 over r into r plus 1, from r is equal to 1 to r is equal to n, using the method of difference, is n over n plus 1. All right, so example 16 says, show that, so here, is asking you to show, but even if you couldn't do the show, you could do A and B. Even if you couldn't do the show part of it, you could do A and B. We're to show that r plus 1 squared minus r squared is equal to 2r. Well, we're to show that this is equal to 2r plus 1. Well, that's not difficult. This is actually equal to r squared plus 2r plus 1 minus now r squared, and this is just what? 2r plus 1. So it's actually very easy. Then A is asking us to find the summation. You know, every time I write this thing, I don't write it good. Some reason when the summation sign don't do good. From r is equal to 1 to n of 2r plus 1. And this would be equal to the summation from r is equal to 1 to n of r plus 1 squared minus r squared. So let's write some of the terms. The first term is when r is 1. So that becomes 2 squared minus 1 squared. First term. Second term would be what? When r is 2, so this is 3 squared minus 2 squared. Then the third term would be what? 4 squared minus 3 squared. I can't write all of them. So next, what? The n minus 1 term. So the n minus 1 term, it would be n minus 1 plus 1 square, which is just what? N square minus n minus 1 square. Then the nth term would be n plus 1 square minus n squared. So let's see what gone. Well, this gone. This gone. See it here. This gone. All right. So one would assume that so as I said, one would assume that r's 4 square would have also disappeared. That this would have disappeared in the next term, because the next term would be what? When r is what? When r is 4. So you're gonna get what? 1 over what? 5 squared plus 1 over minus 1 over 4 squared. So the 4 square term is gonna disappear. So we're seeing that all the terms will disappear. We have n squared here and this gone. I would probably assume, let's see. Yeah. So once you have a term, sorry. So this term would also be 2 terms before it. So this would disappear as well. Now, n squared is already there. So I'm assuming that n plus 1 squared would not disappear. N plus 1 squared would not disappear. Yeah, the n plus 1 square term would not disappear. Because the term here, notice that 2 is when 2 disappear, it's 2 term before it, don't it? So there's no 2 term before this, so this not going to disappear. So it means that this would be equal to minus 1 square. Sorry, minus 1 square, which is minus 1. It's not minus 1 all square, it's minus 1 square, which is minus 1 plus n plus 1 square. This is what remains. You could put n plus 1 square minus 1, which would work out to be n squared plus 2n plus 1 minus 1. It's n squared plus 2n. So the summation from r is equal to 1 to n of 2r plus 1. That summation is equal to n squared plus 2n. So let's do the part B of the question. Part B says, the summation from r is equal to 1 to 20 of 2r plus 1. Using the formula, wherever I see n, I'm going to put 20. So this is 20 squared plus 2 times 20. 20 squared is what? 400. 400 plus 40 is 440.